So hello everyone, let's in today's video I'll be discussing about the the worst combination table, how to do it. I explained it about I explained it in the last video, in the last tutorial video, but I guess it's not clear to many of us. So this video is completely dedicated to the worst combination table. So as you can see it on the screen, the Stadd.Pro software is opened up and all the analysis which we have done up to the wind load calculations as well as the all the combinations we have added up here, and we have made our model. So this is the geometry. We added all the loadings. When you see the loadings, you could see here all the loads. And if you come to the design part, you perform some analysis, like you check some parameter which I have discussed. I've shown it in the last video. Now let's come to the part how to make the worst combination table. So for this, let's come to analysis, here analysis and design. To click for run analysis, this will complete our analysis part, and just stay in the modeling mode, don't open the output file. Okay, and come to the post processing part. Okay, so here this is the post processing, that is Stadd has completed the analysis of the entire model of our truss. Now this green color is nothing but the displacement, because displacement is selected, so I'll just deselect it. Now to calculate the forces in each members, let's go to reports. The reports is here under result belt, and go for beam and forces. Okay, beam and forces. See here it's showing no beam is selected, so we have to select beams for which we need the forces. So you can do it in either ways. You can select each beam individually, like see here, like now you could see that only nodes are being selected here, as you could see. Because for this, come to select and go to the beam cursor. Okay, now actually by default node cursor is activated, we have to go to the beam cursor, right? Beam cursor is activated. So you could either do it in one way, like you could select one beam at a time and go to the reports and go for beam and forces, or else you could go for selection of the entire truss members. Okay, I personally go for this way because it's bit less tedious. So I have selected the entire member in the truss only. Okay, remember not to select the column part, and then come to the reports. It's under results. Okay, so come to beam and forces. Okay, only axial forces. Okay, so in truss we know that only axial forces are taken up by truss, so let's only select axial forces. No need to have these values, shear and moment, and let us sort it from high to low. Okay, so okay, now this is the table for all the beams for all the load combination. Okay, so let's just click it over here. Okay, let's click it, just click over one the beam box and it will be selected. Copy it. Okay, now come to an Excel file. Okay, so this is actually a table which I have like just made it by hand beforehand, so that it will be easy for me to just copy and paste it. Open one more sheet and just copy down that. Now let's clear this shear and moment part, because this is not required. Okay, only the axial forces are required. Now select this. Okay, select this and right click and just filter it out. Okay, filter by selected cells value, right? Filter by selected cells value. Now the most important thing is the sign convention. Now let's go back to my analytical modeling. If I show you for my member number 2, it's located between node 2 and node 10, and for this the green color shows the starting node and the blue color shows the ending node. So The sign convention which I have adopted is, according to Sir, let's suppose this is my starting node 2 and this is the ending node 10. So from start to end, okay, this will be in positive x direction. So suppose a force, maybe it's of 62 kilonewton, is acting away from the positive x direction. Okay, so that will be tension. Any force which is acting away from the node members, they are basically tension. And here, according to the axis, the tension is in negative sign. This sign doesn't plays an important role because at last we'll be only taking up into account the magnitude. So but this convention is useful so that throughout the entire trust, for each member we just go through a single convention, that is, like, don't mix it up. Suppose you have, for this member you have 2 to 10 is the start to end. Suppose when you go for member number 31, you could see that the starting node is 14, like green color is, like, yeah, you can see here the 14 is the starting node, and the node number 16, it is the blue node, that is the ending node. So if you take 16 as the starting node and 14 as the ending node, like the other way around, then again the calculation will be wrong. Okay, so you won't be getting correct result. So either you could follow the opposite way, that is end to start in that direction or start to end in positive x direction. But keep in mind that we have to follow a single direction for our entire truss members. Okay, just don't mix it up. So suppose for any like, what to say, vertical, I mean slide, or not horizontal, what to say, tilted member. Okay, so if this is the starting node and this is the ending node, so start to node, again I have taken positive x because I have started it with this convention. So again here the tension force is like this force is acting away from this node, so it will be negative. So again I'll be getting negative values. Okay, so now let's get back to our Excel sheet. Okay, now we have filtered it out. Now let's concentrate here on beams. Now suppose I will be selecting only my beam number 2. Okay, select beam number 2, don't select any other beam. Okay, select beam number 2. For load combination we have to select all the load combination, just sort it from smallest to largest. Okay, so that it comes in the order. Now coming to the node point, we'll be calculating the force only at a single node, because see, at node number 10, okay, at node number 10, one will be in positive x direction, one will be in negative x direction. Both of them are in tension, definitely, but just the sign that both are in opposite direction. Okay, so we'll be just considering it at one node. Suppose I am taking it as at the starting node. So for me, see here, the starting node is 2, right? So I am taking my node as node number 2, so deselect 10, only 2, right? So 2. Now I'm getting my axial forces. So these are my axial forces for beam number 2 for all the load combination. Like for load combination 1, that is, I guess it was for dead load, is this much. For load combination 19, that is, I guess, 1.5 into dead load plus live load plus wind load 4. So I get this. So our job is done up to here. Now we just have to copy it, go to this file. Okay, I have prepared this file for you. I'll be uploading it in the description box. For suppose 2 is a time member, right? So I have classified my time members, like all the time member under one belt. So 2, just paste it here. Okay, now this for here, actually I've automatically applied a formula, so it's coming. I'll show it to you. Okay, so for maximum tension, actually maximum tension, just do the what to say, the minimum of negative forces, right? So the minimum of negative, what to say, the minimum value will give you the highest negative force, right? Minimum of all this will give you the highest negative force. So you could see that minus 134.12 is the highest negative. Okay, now for compression, go for maximum value of positive value. Okay, the max, I mean the maximum positive value will give you the compression. So just do it maximum. Okay, now similarly for number 11. Okay, let me show it to you. Where is it? Here, right? Sheet number 2. So just go to node, okay, select both, okay, just select. Why I'm just saying it here, because if you don't do that, this beam, like all the beams will not be coming. Okay, now deselect to which beam was it? uh, it is 11. Okay, so come to beam number 11 and beam number 11, and let's see what's my starting node for beam number 11. Yeah, so 10 is my starting node for beam number 11. This is my first combination table. Yeah, so again, just 2 is selected. Okay, see, you have not deselected 2, so it's showing here deselect 2 and select 11, right? So node number, what was it again? uh, 10, right? 10 was my starting node, so deselect 11. Okay, and load combination, it's random, so smallest to largest. Okay, again, just copy it down, paste it here. Okay, similarly for 12, 4, 20, 21, each member. Okay, now similarly for this maximum tension and compression. Now design tension and design compression will be like, design tension will be the maximum out of these values, right? But keep in mind, this maximum value will be like giving you the least negative value, because Excel takes a mathematical value, right? It takes a logic that least negative number will be the highest value. Okay, because we are giving it here as a maximum, or you could do it here, you can change it to minimum, right? So it will give you the highest value of tension. That will be better actually. Okay, so if you do this, okay, so now it's being selecting it only from these two uh, rows. When you complete it for all the members, you will be getting the maximum values, right? So just do it here, minimum of all this, so it will give you the maximum tension, and similarly you should give here the maximum of all, right? Here it should be minimum and here it should be maximum, so you will be getting your design tension and design compression. Just in, and in calculation of your member, design of member, you have to just take the magnitude ones. Okay, this negative sign is just from the purpose of objective of sign convention. Okay, so that was all. Like, I will just show you my worst combination table. Okay, so this was my worst combination table. Okay, suppose for all the members I have did it, and like design tension, see here I have like did it the maximum, like I have did the maximum of all this, so it's giving me the lowest negative value. Okay, because minus 77 is the highest value if you talk in terms of numbers. Okay, if you talk it in terms of integers. Now you just change, I'll just change it here to a minimum, and you could see I am getting my highest magnitude wise highest tension value. Okay, so let me just do it. No, I'll just change it out. I'll just change it out. Okay, okay. Similarly for all those. Okay, so keep in mind, in maximum tension we'll be getting the highest negative value. Okay, I mean the lowest value if we talk from mathematical point of view. And for maximum compression, definitely it will be the maximum positive value. So just this is the worst combination table. It's not hard, just we need to sort it out, just copy and paste. Okay, from here just select the node, both the nodes. Okay, come to beam. Okay, deselect beam number 11 because you have to go for beam number 18. Select beam number 18. Again, coming to load combination, smallest to largest. Again, load, suppose my node number 7 is the starting, no, let it be 12. Deselect 7. Okay, same thing, copy this, paste it in member number 18. Okay, so that is all about the worst combination table. I hope you understood it quite clearly. Thank you.